你是说 YouTube 吗？
对啊，
我好像看。
真假的？我再试一次。
影片拥有整理，请用其他应用程式中播放这部影片的功能，在 YouTube 上发出是很无聊。
可以啊。你再看一次。可以啊。不行吗？
哦，可以了。
因为我刚才关掉了。
Welcome back. Now we're going to talk a little bit about hardware architecture. You might ask yourself sort of why all these terms and words and central processing unit. What I want from this section is I just want to define a few terms so that I can use them in the rest of the course. That's really it. I want you to have some sense of the basic block diagram of things. Now, in the old days, I'm going to show you 3 generations of hardware. I'm going to show you really old hardware from the 60s and 70s. I'm going to show you sort of medium old hardware from the 90s and early 2000s, and then I'm going to show you sort of super brand new hardware that's sort of, this is a Raspberry Pi, and it's the kind of highly integrated hardware that goes into things like the cell phone. So I'll kind of be going back and forth between 3 complete generations of hardware. But the picture and the concepts that I want you to understand is these terms: central processing unit, main memory, secondary memory, and input-output devices. So we'll start with input-output devices. They're the way that this computer accesses the outside world. So things like the mouse, the keyboard, right? I got a keyboard here. Keyboard, screen, all these things. Oh, I don't want to mess up the keyboard there. And so these are the input-output devices. There's a little one. That's okay. Just mess up a little bit. No problem at all. Output devices, screens, and that's sort of how the humans in the outside world interact. Software, the main, inside the computer, we have the central processing unit and the main memory and then the secondary memory. And so it's probably easier for me to take neither the oldest nor the newest to give you a sense of what's going on here. And so if you had a desktop, and maybe you still have one of these junky old desktops at home, they're the ones that are big and they make noise when they start up. They have in them a number of different parts. And the closest thing that a computer has to intelligence is this. Central Processing Unit, CPU is what we call them. And if you look at the back side of this CPU, it is actually a circuit. It's a highly sophisticated circuit with millions of transistors on it, and you probably heard that, millions of transistors. It runs maybe 3 billion instructions per second. What does that mean? Well, that means that an instruction is a set of electrical pulses, maybe 32 little wires or 64 little wires, and at 3 billion times a second, this is programmed to ask what's next. And it pulls what's next in these little electric wires. Well, where does it get the answer to what's next? It gets the answer to what's next out of the memory. And so your program, when you write a program, let me draw this. When you write a program, you create a file on the secondary memory, like a Python file. And then at some point that is loaded into the main memory, translated, and then your program is here. And then when the CPU says what next, your program feeds its first instruction. And then when that's done, the CPU says what's next. It feeds a second instruction, third instruction, fourth instruction. It's called the fetch execute cycle. And these 2 parts, the CPU and the main memory, are what participate. And the main memory is where you kind of live. Somewhere in there, a little tiny version of yourself is in there answering the questions that this is asking. Now you might say, how smart is this? It's not really very smart at all. It's a really fast hand calculator with lots of storage is the best way to think about it. And going back to the 60s and the 70s, this is a piece of hardware from a computer that was the size of a room with probably 20 refrigerators, all with modules that make this up. And in here, while you probably can't see it, you've got resistors, transistors and capacitors, and then wires. The wires are all printed on this printed circuit board, otherwise known as PCB. And so the closest thing this has to intelligence are these transistors. And at the simplest, what they can do is they can sort of make really simple yes-no decisions. And then they also can be used, if you hook them together the right way, to store a little bit of information. And so we say there are millions of transistors packed into this little tiny square right here. It's kind of pretty. I mean, if you look at it, it's sort of, it has like a, it looks almost like a jewel. It's so pretty. And each one of those is a real tiny photo imprinted transistor. And so there are millions of this. And so the difference between 1960 and today is this part gets smaller and smaller and smaller to the point where literally thousands of these things are all squeezed into that little square. And coming back to sort of the mid-grade one, so this one here is the motherboard. This part here is the motherboard because it's the mother of all boards, and it connects everything together. All these components plug in, and that's how they're connected together. And there's a whole bunch of wires that go back and forth on this. And so this is how your program, in a sense, is transported from the memory to the CPU. And so this motherboard connects them. Another thing that's connected to the motherboard is secondary storage. Now, the reason we have to have secondary memory or secondary storage is this is designed to be really fast. The main memory is super fast, and what happens is when the computer turns off, your program is erased from here. And so I originally said that you write your program and you put a file in here, a PY file, and this is the same place that your Word files are and your PowerPoints are, and then the PY file is kind of loaded and translated into the main memory, and then when the computer shuts off, all this data goes away. Secondary memory is permanent. This does not get shut off. And so in the old days, this old day stuff, we used to store on our programs and our files on a hard drive. And you may even have a computer at home where there's an actual physical spinning platter of magnetic media and a little head that goes in and out to read and write the data. And so it actually records magnetically. When you put a file in, it records it, and then when the power's off, the magnetic recording stays here. And so these things, physical disk drives, are kind of becoming extinct because all the data is in little USB sticks like this, and that's a perfectly good version of secondary memory. But at least for us, we can look at these beautiful antique mechanical gadgets that we use to store data magnetically when the power goes off. Now this one here is pretty broken. It's pretty in bad shape, so it's probably not really storing much of anything. So in the summary of this picture, the thing I really want you to get out of this picture is a series of definitions. The central processing unit is very simple. It's the closest thing computers have to brains, but it wants to answer the question what to do next, but we have to feed through memory the answers, which is your programs, and then we have input devices, output devices, the main memory, and then the larger permanent storage in the secondary memory. So where you live inside of a computer is basically in the main memory. When you write a program, you type it in. The computer, you outside the computer are typing on your keyboard, and you're typing Python commands into a file, like if x less than 3 print, right? And then that gets loaded into the main memory, and so this is a creative version of yourself. It's your instructions that are going to be run, and that program ends up in the main memory, and then it's run. So this is sort of where you live inside the computer. Think of it that way. You're living in main memory when your program is actually executing. Now it turns out that the instructions that this central processor uses are a series of zeros and ones. And when I said like 32 zeros and ones or 64 zeros and ones, simultaneously are fed into this for each of the instructions. We use a language called machine language. And I would love someday to teach you machine language, but we don't have time right now, and that's more moving towards being a computer scientist when you start learning machine language. But basically, we don't have to worry about that too much. We write Python, and we write in Python, and then something effectively translates it into machine language, and then machine language is the thing that runs and runs and runs and runs And so someday you might take a look for that, but that's more of a computer science thing. And the software that does this translation, which is either called a compiler or an interpreter, we can talk more about that when you become more of a computer scientist. But for now, we're going to worry about how to write this code, and the rest of this sort of is going to fall by the wayside as we go forward. So I got a couple of videos here. This one video, hopefully the YouTube URL is still good. If not, we'll try to find another way to get you linked to a good copy of it. But basically, these, as I said, there are millions of transistors in one of these things, and there's a lot of electricity going through these things, and when your computer heats up on your lap, it's this little part here that's working really hard, doing things 3 billion times a second. So someone has made a video, not a very good video, but it's from a long time ago, where you take the cooling part off and you watch what happens to these CPUs when they're doing all this work 3 billion times a second using all this electricity and they're not properly cooled. Another cool video that we have is a video of hard drives and how they actually spin in reality. This one is totally messed up because I've been beating on it for years and playing with it, using it in all my classes for years, so it's in really bad shape. But this video shows you how that works and how it actually spins in reality. And you'll hear noises that if you had a desktop computer, you'll kind of recognize the noise, and then you'll have an idea of what's going on inside that computer as that secondary storage is moving around. And like I said, secondary storage is becoming less and less relevant at.
这些东西我都知道啊，只是我要看它，我要看的就是这些硬件在软体里面扮演什么样的角色，才是要看的。硬体我知道了。
As we move to solid.
这里你硬体你不知道，你可以问我。看这可以下载下来，很小。
Welcome back. Now we're going to talk a little bit.
很小。
So now we're going to talk about Python as a programming language. You probably noticed that I'm wearing a sorting hat. The reason I'm wearing a sorting hat is that where I work at the University of Michigan School of Information, we are in a building called the North Quad, and you can look it up on Google and find a picture of it if you like. And I think it's designed to be like Hogwarts. It's got a where I work at the University of Michigan School of Information, we are in a building called the North Quad, and you can look it up on Google and find a picture of it if you like. And I think it's designed to be like Hogwarts. It's got a little center. It's got this outside bit. It's got a really cool cafeteria that looks like owls might fly through it. And so we moved to this a few years back when I started teaching Python, and I was teaching my very, very first class in this building, which we sort of lovingly call Quadwarts, because it's North Quad, and we thought it was kind of like Hogwarts. And so I'm like joking, and I'm like I wore my robes to class, and I said, "Welcome to Quadwarts," and you have to wear your robes every time to class, and I was being funny. And I said, okay, it's our first class, we're teaching Python, and let's do a sorting ceremony. I didn't have a sorting hat back then, so I have a sorting hat now. And so that's cool, and I'm like, I think I'm going to be in Gryffindor. And they told me, the students said that I couldn't be in Gryffindor. And I'm like, why can't I be in Gryffindor? Everybody wants to be in Gryffindor. And they told me that I was teaching Python. Python is like a programming language that's based on a snake. And even worse, my name's Charles Severance. And I'm like, Severus Snape. And so they basically told me that I had to be in Slytherin. So since then, I've bought many Slytherin items. I got Slytherin wands. When I graduate, you'll see my Slytherin wand. I got a sorting hat. So you'll see me drinking tea throughout the class from my Slytherin cup. And so I guess I'm just doomed to be in Slytherin. I don't know if that means I'm a good guy or a bad guy, or a good guy that seems like a bad guy, or a bad guy that turns out to be a... Right, it's a lot of books. So, the whole thing about being in Slytherin is that you can talk to snakes, because you can talk this weird language that others don't understand. Python's like that. Python's a language that most don't understand. You, of course, will begin to understand it. It's a weird language. It's strange. It's not easily understood by others. We call ourselves Pythonistas. And Guido van Rossum, over 20 years ago, invented this Python language that we have grown to know and love and has become so important. And while I'm going through all this like snake stuff, it turns out that that is not at all why Python was named Python. Python was not named for a snake, even though we use the snake motif all the time. It turns out that what Python was named for was Monty Python's Flying Circus. And the reason is that Guido was trying to capture an air of play. Most programming languages in the 80s when Python started were very, very serious and very complex, and you had to be really serious to figure them out, a lot of math geniuses. And Guido thought, I could probably write a programming language that wouldn't be that hard, would be fun actually, which would be enjoyable to use, but let's not make it bad, let's not make it weak, let's make it both powerful and enjoyable. And so that's why Python turns out to be such a perfect language to use as your first programming language, is that it's designed to be your first programming language, but it's also powerful. So many times you build a first programming language that's weak and not capable of doing a lot of stuff, but Python has this wonderful, easy to learn, and powerful and useful. And so there we are. Welcome to being a Pythonista. Now, as you learn Python, remember you're talking to a snake, and this is a language that you don't already know. You are going to make lots of mistakes, and the computer is going to seem to judge your mistakes harshly. You will learn the word syntax error a lot. And if you're like me, I think back to the first time that I was programming. I was typing stuff on cards, and you'd bring your card deck up and you would hand it to the computer and you'd read it through the computer, and then the computer would come back and say syntax error. Sometimes it took like several hours to get back the results of your program. You're going to get to do it in seconds, but in the old days when I was young, it took hours sometimes. And then all you get back is a syntax error. And when I first started programming, I grew to kind of hate the creature that lived inside the computer, because I thought that the creature didn't like me. I thought the creature was value judging my programs. I would write this thing and I'd think it's perfect, and I would hand it in, and the computer would say syntax error, and I'm like, huh? What's up? Syntax error. And then I would like, oh, okay, I'll make my program better, and here you go. And say syntax error again. And the thing that you're going to have to learn is that syntax error doesn't mean that Python thinks you're bad. It is not a judgment of your ability as a programmer. It is not a judgment of your potential to be a programmer. Syntax error means Python is lost. You are learning Python's language because Python can't learn your language. You're smarter than Python. We can teach you. You can learn, but Python can't. And so when it says syntax error, even though you feel like it's a rejection, syntax error simply means that Python is lost. It just doesn't have really friendly words when it says it's lost. It just goes syntax error, which literally is exactly what's happening. Your syntax is not something that Python does. It's not something that Python understands. So just understand as you go through the next couple of weeks that you will be frustrated. It's not because you're a bad person. It's not because you're never going to figure it out. You will figure it out, and you will get it. And you have to sort of trust us as we go through the first few weeks and learn the basics, and then as we connect the basics together, then this thing will make a lot more sense. I remember when I was first learning to program, I mean, I would be like, lost, 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 lost. Oh, wow, I love this. And I expect that many of you will go through that exact same feeling, so you have to trust us. So up next, we're going to actually talk about the Python programming language.
所以他是要做一个程式去学舌语。
不是，他的意思是说，他一开始是在讲说 Python 呢，很多人都以为它是因为就是它是一条蛇，然后所以他们就想说这个 Python 是以蛇命名的一种语言。那他的意思是拿蛇来做比喻，说因为 Python 它没办法学习我们的语言，因为我们才是制造 Python 的人，我们是制造这个语言的人。就是有刚才那什么 Guido，
我以为它是蛇。
不是。然后我们要跟蛇去沟通，那我们要学会蛇讲的语言，所以我们在学的是一个未知的语言，那我们会遇到很多问题。那个 syntax error 就是文字上面的错误，也就是说你在程式代码里面打错字，它会告诉你说你打错字了，但不代表你是错的，代表你是打错字，可不代表你写的东西是不好的。那他刚才也讲说，在他年轻的时候，他刚开始学语言的时候，因为你应该没看过那个 floppy 就是磁碟片，你有看过吗？就是最早期的 USB， 也不能说最早期，应该说 CD 片呐 ，CD。然后这哈，这你有看过吗？
你往下滑了，不是啊，你刚刚不往下滑？
我滑了。
对，有延迟，没有看过。
那表示你真的完全就是00后基本上不会经历这个东西，因为我小时候也没有见过几片这个东西，这个东西是我有意识以来，我可能就见过那么几片，在我爸的公司里面而已。那它就像 CD 片一样。那他们以前早期的时候呢，还不是用这个，是用类似卡带夹的东西去插入到电脑上面。那电脑他们就会读取你的程式代码。那因为以前的程式语言很复杂，然后它又很正式，很难，所以后来就是写 Python 的这个人呢，他就想说那大家都把这语言写得这么复杂，然后每次读取的时候都要很准确，你才可以真正的去应用这个程式。所以他就想说写了 Python 这个语言，就大家可以比较欢乐一点的去写这个语言。可是一般来说，你的语言如果不够严谨、不够正式的话，你的运算能力又会比较差，然后又不够强大，所以他就把 Python 做的就是比较友善，可是又不会说它的效率不好，所以它是一个很有效率，并且是相较其他程式语言来说比较容易入门的一个语言。所以它让我们学的东西就是学会怎么跟 Python 沟通，然后让 Python 去执行我们想做的事情。所以它不是蛇的语言，它是说我们要跟蛇，把它当蛇一样，我们要去跟它去互动。
Camry.
这边应该都可以不用看了。还是可以看一下。
Is it working?
Is it working?
It's working.
Selfie?
Yeah, it's my selfie cam, my gimbal selfie cam.
It works great.
Yeah. So this way I can tape my meeting of Alan Downey.
Wait.
That's gonna be sweet. The moment that I meet Alan,
Palpable.
it is.
Very cool of you.
Folks, that's Alan Downey, who started the whole Think Java, Think Python revolution back 1999, and I'm going to meet him now for the first time.
You can ask him that question that I should have asked him a long time ago. Right?
Exactly. We're co-authors. Yes. We've never met in person. We talked on the phone. This is a famous Jeff Eltner, of course.
It's made famous by this guy.
Yeah, well, everybody got made famous. That's right. So the first question I was asking Jeff, and he doesn't even know the answer to, is why did you choose GFDL back in 1999? That was before Creative Commons, before OCW, before everything. What possessed you?
Actually, the first version of the book, I put it under the GNU free...
GFDL.
No, not
GPL.
The GPL.
Oh, you did GPL.
Because I didn't even know about the FDL.
And then somebody got a hold of you
and said,
from MIT?
Then they said, wait a minute, this is documentation, this is not code. You should use this other license. And so I switched. And then when Creative Commons came along, some of those licenses have been useful.
Yeah.
Actually, part of the reason that working with O'Reilly has worked out very well.
Yeah.
I do things usually under a non-commercial Creative Commons license, and then that's kind of a compromise. It's not ideal.
But those are the details, the why question.
No, the non-commercial is, I think, a beautiful thing. And actually, Creative Commons is thinking about getting rid of it. Yeah. And I'm sad about that, because I think it's a fine middle ground. For e-copies can be delivered free, and no one feels bad about that. Print copies you make money off of, so it's pretty cool.
I agree. I think there's a nice use. A number of English language books.
Okay.
So we have to talk later.
Okay. By far the largest office hours that we've ever had. We're in India, in Bengaluru, and it is the IT capital of India. We don't have time for you to meet each one, and everybody can sort of wave and say hi. There we go. Make sure we see everything.
我靠，一堆大神坐在这里。
It's working pretty good. The blind programmers.
他在印度的邦加罗尔。很好笑啊！就印度不是都数学闻名吗？然后下面都是一堆超级金头脑的。好，第一个礼拜的课上完了吗？好像还没。好，上完了欸。第二周，等一下，这个是，哦，没事。没错。Important reading using Python in this class. You to install Python on your computer. If you have a desktop or laptop, there are even some Python applications available. But if you do not have a computer where you can Python, you can still complete this class because we have a version of Python that runs. You will see various links that allow you to. Okay. We recommend that you use the end tone for this course. We prefer it because it works the same on Windows. We can talk about all course demonstration. 有边冲啊，就直接开着。
看这个，我想问你怎么那么早起床？我要实施3天都在家的垃圾行程。
Items not currently set as the default handler. Would you like to handle? Okay. Hackable text editor for 20. 你可以跟我一起学习，当个良好青年。
讲的好像很垃圾一样。
没有啊，是一起变好啊，变得更好。我什么时候说你垃圾了？你自己说。有时候想往前走，却又忍耐不住频频回头。
好酷哦！
奔跑在风和日丽，突然间和狂风暴雨。给承诺。有时候。If you do use and be aware that user input is not supported, or run from the editor rather comment like already have the text editor like to using it no problem using it which also includes many signs and data. Use spider development reference use
So welcome to this week. Last week we talked about like the theory of programming and computer science and the Macarena and all that kind of stuff, and that's cool.
啊？
我说你直接超前进度。
它又没有很多，那样子大概也就1天的量而已啊，不会很多。要高速学习，你有没有看过那个超速学习的一个影片？你要看吗？我可以为了你再看一次。要吗？
为什么学霸在考前总是没自信？为什么学校要让有人气的学生上微积分？为什么我们总是学不会？欢迎回到文说书。
为什么会有2个人在看你直播？
一个是我，
你也算一个人。
你写考。
不是啦，靠腰，我是说，就是自己也算一个。
算了，因为我开着网页啊。
嗨，大家好，我是 Vincent。学以致用这个节目主要是讲述将所学变成现实生活中可以应用的知识。而今天要谈论的这本书《超速学习》，就是基于最后你会使用该技能的场景下去设计的学习回圈。在这之前，要先告诉你，超速学习这个书名可能会让你觉得这是一个换汤不换药的学习鸡汤。它是鸡汤还是宝典，得由你来做决定。 我们首先来谈谈我们为什么需要超速学习。在1年时间内读完麻省理工资讯科学的课程，并通过期末考，利用1年的时间学习4门语言。这2项挑战是作者史考特·杨在写这本书之前完成的。他因为这2项挑战而获得许多关注，并而接触到更多不同领域的顶尖学习者。他将这些人与自己的学习经验化作许多可以重复使用的工具。好比我们可以在学习一门课程之前，先进行考试，再开始上课。这种方式能让我们的大脑变成探针，我们会主动去搜寻课程中可能会出现在考题上的内容。这些工具在书中比比皆是。在我说明这些工具前，先想好你要学习的目标，无论是数学还是化学、室内设计还是货币加密，带着你的目标，跟着我开始超速学习。后设学习，我们从终点看向起点。试想在你的学习过程当中，你会需要什么样的资源？你可以向该领域的专家请教，或是付费找专业家教。若这项技能是学校里有开课的，搜寻一下，你甚至可以找到推荐的教科书。找完资源之后，接着你就要问自己最重要的问题：你学会这项技能之后，你希望它会被使用在什么时刻，用什么方式？这项问题能帮助你锁定你所需要知道的知识。若是你的目标是写出一款应用程式，你应该将更多精力放在学习编写程式，而不是运算逻辑。这个问题也能引导你走向下一个杀手级工具——直接学习。告白最怕不够直接，学习也是。但这是教育单位容易搞砸的一件事，因为课程上的安排为了普遍性原则，会让学生的学习时间平均分配在多种科目，这就很容易导致学生毕业之后仍然不具有该科系应该具备的核心知识。而直接学习的存在，就是为了修正这项问题。直接学习的重点在于，学习活动的进行方式永远要跟这项技能最后会被使用的环境有关。例如，我们最终目的就是想利用绘图技巧找到一份界面设计师的工作。那我们一开始学习时，就应该让自己模拟这个环境。例如，你发现市面上最常用的图形界面软体为 Illustrator， 你就该将你的所有练习都用这款软体来操作。这样的跳跃式学习非常痛苦，没错，远比你看着线上影片一步一步带着你画原型来的困难许多。但这样的学习方式能确保自己在学习结束之后，一定能最接近一开始所期望的。直接学习是个很好的开始，那然后呢？用实作找出该被强化的地方。Kevin Durant 说起他在2008年奥运时的经验。那天是个假日，教练宣布今天可以自愿去球场练习。当我搭乘巴士来到球场时，我发现 Kobe 已经坐在那边，这给我莫大的启发。他已经是球场上最强的怪物，为什么还要如此努力？后来我才知道，早在1小时前 ，Kobe 就已经来到球场练习。虽然 Kobe 这位篮球巨星在41岁时因为事故而与世隔绝，但他的黑曼巴精神永远值得我们仿效。问题在于，我们该将练习的重点放在哪呢？沿用刚才所提到的直接学习，当我们将环境设定成最终使用场景时，我们一定会遇到许多问题。例如，想要提升演说技巧的你，可能会发现自己说话的语调不对，想要与观众互动的地方太过突然。我们能利用这些遭遇到的瓶颈来帮助我们有效的练习。这也是该书提到的一项神奇工具——连贯法。它的意思是指，当你尝试去做一件事，你可能会发现自己被某个地方卡住了，在仔细去修复这项问题时，又会发现另外一个地方的不足。这些发现就是你可以重复练习的地方。这种做法可以让你的学习过程化为主动。想象你现在坐在教室里，阅读一本教导你如何演讲的书，你所获取的内容都是书本所决定的。这种状态下，你是在被动学习。而当我们已经发现问题所在，试图去找出解答并大量练习时，我们是将学习化为主动。我们带着疑问去找寻知识，学习成果也就不同以往。而在你确定目标并不断提升能力时，也会产生一个新问题：遗忘。已经有许多实验证实，一个医生职业的年数与他的医疗品质之间呈现反向关系。也就是说，你最依赖的那个老医生，他的技术可能比一个刚毕业的新鲜人还要更差劲。在宋朝时期，医生发明了印刷术之后，有人感叹这项发明让人们学会遗忘。而关于遗忘的这场战争，我们该如何因应？关于我们如何记得一件事，我们可以先看完这项实验。心理学家杰佛瑞·卡比克与珍妮尔·布朗特一同进行一项研究。他将学生分成几组，其中一组的学生可以任意翻阅待会要考的题目，另外一组则是只能复习一次，最后一组则是不能翻阅课本，只能尽可能在脑海里回想内容。 而在考试前，实验人员要求学生评估这次的考试分数，不限次数复习的学生所预测的分数是当中最高的。好巧不巧，这也是我临时抱佛脚后的疯狂想法。考试分数出炉，只能凭空回想的那组成绩明显高于其他组。这项实验证明了2件事：第一个是人类对于自己是否确知一件事情的能力不佳，但由于重复翻看课本这件事情的困难程度明显不及于自由回想，这种感觉会让我们自认为已经学会了，以至于错估自己的所知程度。第二件事，正是由于不打开课本进行自由回想这件事所存在的痛苦及不舒服感，让大脑认为这件事肯定非常重要，以至于让我们反而记得更清楚也更深刻。由此实验得出，试图从记忆中换回知识的过程本身就是一个强而有力的学习工具。我们能如何聪明使用这项秘密武器呢？书中提供一个小诀窍。一般而言，我们在上课时或在自行阅读当中写下来的笔记多半是课程重点，而作者则是建议我们可以将这些习惯改成写下问题。假设你现在正在为这部影片写下笔记，过去的你可能会写下：一、立下目标，从最后的使用场景中思考如何学习；第二，在学习的过程中使用连贯法来解决瓶颈，并使用回想方式来复习。现在的你可以改成：第一，为什么学校提供的课程多半无法实作在职场上？超速学习是如何解决这项问题的？第二，如果重复练习是达到结束的必要过程，那如何找出需要练习的环节？哪种复习方式能让往后的自己更加深刻记得这些呢？写完之后，在这些问题后面写下答案所在的页数。往后的你在复习时，便能从脑海中提取记忆，而并不是单纯的死记硬背。若你持续努力的学习，最后做出了一点小成果，你在开心的同时，我得向你说声抱歉，这只是另外一个开始。酸言酸语的赠礼，你在浴室里唱着林俊杰的学不会，那时候的你自以为是个真假音准的高手，你向父母展现你的歌喉，他们的反馈既中立又不敢说出实话，于是你将录音档上传到全是陌生人的脸书社团，第一个留言写着：我到底听了什么？面对他人的评价，与前面所提到的直接学习有相辅相成的效果。我们让自己直接去挑战这项技能最后会被使用的场景，并从中收到许多好与不好的反馈。我们大多数人都会本能的抗拒严厉而直接的评价，因为被他人告知自己的缺点，真的不是很开心。但在许多时刻，阻止我们继续前进的并不是坏评价本身，而是由于我们担心坏评价的预设心理。如果你真的想实现超速学习，让自己置身于会受到评价的环境当中，是个绝佳办法。由于我们知道他人会看到我们的学习成果，我们会更加努力，也更有目的性。这种心态上的改变，实际上已经比评价本身更具有价值。而作者在书中特别提醒，千万不要因为一些毫无根据的评价而修改自己的方向。假设你在网络上的某篇文章受到特别多的关注，你需要确定是否有某个公众人物分享过你的文章。若你不经查阅而将未来的每个作品都模仿这篇的写作方式，你可能就会掉入过度反应的陷阱里。你在不断练习与听取反馈中得到成长，接着你要如何确定自己是否学会了呢？费曼技巧。理查·费曼曾参与原子弹开发，并在1980年代参与调查太空者号灾难。因为在量子力学上的贡献，他在1965年与朱利安·施温格一同获得诺贝尔物理学奖。会提到费曼，是因为我们得借助他聪明的学习方式。现在你拿出纸笔，开始写下。假设你今天要跟一个对你正在学习的技能毫无所知的人解释你的学习成果，你该如何叙述呢？你可能会在过程当中发现自己的逻辑缺失，或是无法使用平易近人的方式来解释某个专有名词。这些发现正好能提醒你哪些地方的不足，接着你就可以使用前述所讲的工具去加强。这项评估技巧可以有效避开自认为已经懂的问题，也可以确保对于这项知识的完整性，让整个学习回圈能够运转。在我写一本书的书稿时，最怕遇到的就是一本书的内容太多精华，而这本书的内容真的很难断舍离。书中有9个学习法则，每个法则中又有许多作者提供的调整工具，好让这些法则能够适配在不同的技能上。我也正在使用其中几项工具学习如何阅读。理论上，理论跟实践是差不多的，但实际上它们并不一样。还能什么？赶快用这些秘密武器成为下一个超速学习者。
But now we're going to start writing programming, writing programs using Python. And one of the things we're trying to encourage you to do is install Python and run it, because sooner or later you are going to have to do that, right? You're going to have to install it and run it. We've got a bunch of videos, but in courses 1 and courses 2, you don't actually have to do that. Now we know that some people are using iPads or Chromebooks or something else, and you can't install Python. And maybe you're at a school that can't install Python. So it's great that you can write Python programs using software we've provided in the browser. And we have this Python playground. And so as you go through the course, you'll find assignments that you have to do. But what this is this is an ungraded assignment, Python Code Playground. And so it's launched externally using a technology called Learning Tools Interoperability. So it's going to pop this open in a new tab. So you see that it's in a new tab, right? And it's the Python Playground. Now, this is kind of like the auto grader, except it has no expectations, and you can write any code that you want. Okay, and so let me hit the reset code button, and you can always go back to the default code, and this is the code that's there for you. And if I want to run it, I can just say go ahead and run this code. Right? And so the code runs and the output's over here. So it actually ran the Python and the code came out over here. Now this is a file. This is like chapter 7. It's even from course 2. So the default code here is probably not what you want to play with. You can play with something like print play exclamation point and run that. And so it runs the code and then your output comes here. Now there are 3 files, which is later, chapter 7 and later, that you can use. These are the sample files that we use throughout a lot of the assignments in the book. And away you go. And so you can do whatever you want here. It's not being graded. There's no grade being sent back to Coursera. And so away you go. And if you're writing Python on your laptop or your computer, you're way better to just learn how to do Python there and then paste the code into the autograders later. But if you have no access whatsoever, that's why we give you the Python Playground. If you want to do this in Python 2, because the course is taught in Python 3, there's a little button down here that says switch to Python 2, and so you can run Python 2 code in here as well. If you know Python 2, in the first 10 weeks of the class, you can actually switch back and forth between submitting your assignments in Python 3 and Python 2. But in this case, now the other thing that's cool about this is that you aren't going to see this button, you're not going to see any of those buttons. This View Student Code allows our teaching staff to take a look at your code. And so we don't allow you to paste code into the forums. So what you can do is you can ask for help in the forums, and the teaching staff can go in and view the student code, type in your name or email, and then find the code that you last put in. So you can put something in here and get some help on it. The teaching assistant can see your entire code, they can run your code, they can do all kinds of things. And so it's a great way to communicate with the teaching assistant. You sort of leave your code in the playground, you ask the teaching assistant, and then they go take a look at your code. And when you're all done, you simply press done, and we're back to week 2. But like I said, I really would personally prefer that you build the skills in running Python on your laptop as quick as possible. But if that's not practical for you, then that's why we have the Python Playground here in courses 1 and 2. Hello, and welcome to my video that shows how to get started and install Python on Microsoft Windows. Okay, so it's not too hard. We're going to both install Python 3 and we're going to install text editor. And so I'm just going to go into Google and I'm going to say install Python 3. And my top link is downloading Python. And there is my link for downloading Python 3.5.2. This version of my class uses Python 3. I have an earlier class that you may have seen that uses Python 2, but in this class we're going to do this. Now it might take you a while to download this. I've actually already downloaded it. Now the other thing we need is a programmer text editor. And you can really use any programmer text editor. We've used Notepad+ in the past. We've used JEdit in the past. I like Atom, atom.io, Tom.io, mostly because it works the same on Windows and Mac and Linux. But you can really use any text editor that you like. Just don't use Word or text edit that comes with the operating system. You need a programming editor that it doesn't mess with weird characters or weird lines or strange formats. You must have a real programmer editor. So I've already downloaded this as well. And so I won't waste the time waiting to download it, but let's go ahead and do the installation. So these things ended up in my downloads file. So go to downloads, and I'll start installing Python 3.5.2. Now it's going to ask me some things. Add Python 3.5 to the path. Yeah, that's a good idea. Install the launcher for all users. I'm going to add that. Maybe you will, maybe you won't do that. It's going to tell me where it's going to install it. Install now. Of course, it's going to ask me for permission to do these things. And now it's running through the installation. Okay, so run the Windows, and so here's this command line, and I should be able to type Python here. And so now I'm in Python 3.2, and this is the chevron prompt here is the Python interpreter, where it's asking for Python commands, and I can say print hello world. Of course, this is what we tend to print all the time. I can make a mistake. I can say right, and it'll complain to me. Now to get out of this, I can either type Control-Z or quit. In this case, I'm going to type Control-Z, and I'm back to the prompt. A couple of things. I can do a dir to see what folders and files I have, and that is like my desktop. And then the cd command tells me where I'm at in the folder. That means I'm in the users directory, Dr. Chuck. Okay? So I have now installed Python. I ran the Python interpreter to verify it. I said print hello world. Okay, and so now what I'm going to do is I'm going to actually install Atom. I already had this down. Kind of telling us what to do. I'm going to actually just close all these windows, close this window, close everything, and I'm going to create a file. I'm going to say print, in this case, let's see if I can make this bigger. I can make it bigger. So I'm going to type print hello from a file. Okay, and I'm going to save this. I'm going to say file, save as, and what I'm going to do is I'm going to go to my desktop, and I'm going to make a folder on the desktop. I'm going to call this folder PY4E. So I now have a folder on the desktop. Move this here, I'll move this here. Oops. And I'm going to go into PY4E, and then I'm going to name this file first.py. And you'll notice that when I save this, it syntax highlighted it. That's one of the nice things about a programmer editor. Okay, and so it says, oh, it's got a suffix of .py, so therefore it knows that it's supposed to look pretty with Python and make this one color, make this another color. The other thing that you'll notice is that I now have a folder called PY4E. And if I'm in this command line, let me just start that up again. I'll show you how to start the command line again. command. Now, if I do a dir, I see the folders that I'm in, and one of the folders that you can see here is the desktop folder. So I'm going to say cd desktop, and then I'm going to type the dir command to see what folders are in the desktop. These folders are the same as these folders. These things are kind of virtual folders. py for E is py for E. Now I can type cd, which stands for change directory, py for E. And I can do a dir, and I see first.py. And that's the same as if I'm diving into this folder. Here's this file, first.py. Windows hides the suffix, which is somewhat annoying and frustrating, but that suffix is there, that file is there. And so for me, one of the things you got to figure out in Windows is how to make sure that you are in the same folder, users, Dr. Chuck, desktop, py4e, and that's the name of this file, and here as well. And now I'm going to run this program. I'm going to type Python first.py. And you see that it ran the Python code. Okay? Another way you can do this is you can type first.py. And that's because this file association has happened in Windows. This doesn't work in Macintosh. This only works in Windows. That all files with .py are expected to be Python, and it knows the Python interpreter where to run. Okay? And so I've got Python 3.0 installed, and that gets me started, and so I hope that this little introduction about getting things started and writing your first Python program.
Hello, and I'd like to talk to you about how to use the snipping tool to do a screen capture. There are other ways to do this, but the easiest way is the built-in screen tool, and I'm doing this and this is how to do a real simple snip.
わかんない。
to see here is the desktop folder. So I'm going to say CD desktop. And then I'm going to type the dir command to see what folders are in the desktop. Keep. These folders for E. Now I can do a dir, and now you see first.py. And that's this.
怎么不行呢？
Same as if I'm diving into this folder. Here's this file, first.py, Windows desktop. And one of the folders that you can see here is the desktop folder. So I'm going to say CD desktop. And yep, I'm going to actually document what folders and files I. So I'm going to Control Z, and I'm back to the front. A couple of things. I can do a dir to see what folders and files I have, that is like my desktop. And then the CD command tells me where I'm at in the folder. That means I'm in the users directory. Command tells me where I'm at in the folder. That means I'm in the users directory, Dr. Chuck. Okay? So I have now installed Python. I ran the Python interpreter to verify it. I say print hello world. Okay, so it says, oh, it's got a suffix of .py, so therefore it knows that it's supposed to look pretty make this one color, this another color. The other thing that you'll notice is that I now have a folder called py4e. And if I'm in this command line, let me just start that up again. Let me show you how to start the command line again. Command. Now, if I do a dir, I see the folders that I'm in. And one of the folders that you can see here is the desktop folder. So I'm going to say CD desktop. And then
为什么呢？
These folders are the same as these folders. These things are kind of replicated. PY for E is PY for E. Now I can type CD, which stands for change direction PY for E.
什么鬼啊？为什么？干你娘！为什么找不到？可是他读到另外一边的，不可能吧？没有啊。
天水是，哎呀，
啊，靠背！我操！什么鬼啊？那为什么会这样子呢？对啊，怎么会这样子？ 嗯。扯欸。嗯。 该可以了吧？对嘛，干你的！真的是在逼我哎。
所以你打这件是要让他把那个东西放到桌面上。
没有，因为我有一个软体叫做 OneDrive 嘛，然后 OneDrive 这东西就北蓝，它会把我的就是路径吃掉，所以刚才我一直就是打那个 dir， 就是因为我要找到我桌面上的物品嘛，就是现在看到这一些，可是因为它一直我的档案一直都存在 OneDrive 里面，所以它会跑到那个云端上面的这个系统。然后，可是因为我这云端系统它的路径跟我电脑上面这个 CMD， 就是打代码的这个程式里面所设定的初始设定的地方路径完全不一样，所以它一直认到的是我电脑本身的这个桌面路径，而不是我 OneDrive 上面的，所以它认不到，所以我一直叫不出来这个东西。妈的，真的是天选之人嘞！还好我够聪明。啊干！那我东西是不是不见了？等一下，那这样我那个东西是不是不见了？是吗？哦，那没关系，我重设一次。嗯？什么？
我说我手机有，但电脑没有。
有什么？
OneDrive。
正常来说，电脑应该都会放。耶！终于。我毫不付出，我只想说，我认真的爱过。两个相爱的人究竟犯什么错？需要爱的如此折磨。 耶，开心。你困了对不对？嘿嘿。骗。
我就看你还整天睡觉。
当然是我啊，我是正常人。
The number of people.
好啊，这一集看完。
算了，你不用早起啊，可以看到自己。
Just looking around in 2005, 2006 at the number of people applying to study computer science, and just this sudden horrible realization that we'd driven off a cliff, and kind of like Wile E. Coyote, we'd driven off, got off a cliff, and then we looked down, and yeah, we're in real trouble. So yeah, it was just trying to eke our way back towards that 1980s world in which every child who wanted to be a computer programmer had a machine that they could use to learn on. Then there was this period of 3 or 4 years, 5 years, where we were just kind of grinding through, iterating different processor architecture choices, different vendors. So we started off with something that actually looked a lot like an Arduino. Turns out you could take one of those. We wanted it to be a real computer. We wanted it to be a computer with a user interface. And it turns out you can take those microcontrollers that are in the Arduino, and you can make them generate a video signal if you clock them hard enough and you write the right software for them. You can make them generate a component video, a standard definition component video signal. And so we started off. I still have it. It's a piece of Veriboard, which is about that sort of size, which has an AML chip on it and a block of SRAM, and it gives you actually a very kind of a 1980s computer experience. And the lovely thing about it is because they're all 0.1 inch through whole components, you can build it yourself. You can build it in. It takes about an afternoon, a rainy afternoon. You can go in with a piece of Veriboard and some chips and come out with a computer. And that seemed like a really nice idea. But when you take a new show to children, what you find is that they're not really. It's not exciting. It's not contemporary. It's not modern. People.
你有看过旧的电脑吗？
1980s, we didn't necessarily get them.
多久？
就是一台很大一台的那个。
哦，我有看过照片。
哦，我以前家里有我加拿大家里好像还有。
到底这样讲，这是多久？是多久以前？
像这样子的我家以前差不多就长，比这个大啦，比这个大一点，可是就差不多长这样。哦，差不多。
有，我看过，我看过实体，我看过。你知道我们看过吗？我在我们学校，就是大学学校的库房看过。
哦。
就机房，对，我看过。我亲眼看过，我看过比这个更。
We lived their way into our lives, right? They snuck into our lives, and once they were in our lives, then we learned to program. We didn't necessarily get them, and so really, I think probably most of that 5-year journey was about seeing if we could reconcile the idea of a $25 computer with a feature set that would make it attractive to a modern child. And another thing we found with all of these, with that and with some subsequent architectures we tried, what we found, all of which were based on very special purpose pieces of hardware. What we found was we were having to do everything ourselves. So we were writing our own SD card drivers and our own terminal software and our own keyboard drivers, and you end up doing an enormous amount of work because you've chosen to you've cheaped out on some aspect of the hardware. You're using some wacky DSP as your processor. You're writing this giant software stack yourself, and it was only really at the point where we got into a point where we put an ARM. We were lucky enough, so my day job for most of that period has been working for a company called Broadcom. We're a big, fabulous semiconductor company. We make chips for communications. Pretty much every communications application has a Broadcom chip. We were looking at a range. We took the Raspberry Pi concept through a series of Broadcom chips, seeing whether we could get something compelling. And we were very lucky that towards the end of that period, one of these chips ended up with an ARM in it. So we made that leap from from this special purpose world with us doing all the work into a very general purpose world where really what we're making is an ARM Linux box. And so we're a not-for-profit. Our funding came from a couple of us throwing money in a hat. Quite a lot of money in a hat, but it was quite a big hat. But it was that seemed appropriate. But the thing that was really surprising to us after we announced in 2011, after it kind of almost leaked out, it was just a kind of a slip of the tongue. We didn't suddenly we were surprised by the level of interest. And it became apparent to us that we really weren't going to be able to manufacture these. We weren't going to be able to manufacture them in anything like the numbers that were going to be required to suit the demand. And that's why you kind of see us, if you go look back at our website, you see us in 2011 talking a lot about manufacturing. And then towards the end of 2011, start 2012, our entire business changes, so we become a licensing company. So what we are now is it's a very capital light licensing company. We design this, we work on the brand, we work on the software, we work on the hardware, but all of the manufacturing and the capital provision and the logistics, they're all provided for us by our partners. We have a couple of partners, RS Components and Premier Farnell, who are kind of multi-billion-dollar electronic component distributors, and that's really the thing that's allowed us to go to scale. The really wonderful thing is that we were able, in terms of who does the manufacturing, like everyone else, they don't manufacture, they commission manufacturing from a third party, from a CEM. The wonderful thing for us was that last year we were able to move our manufacturing back. So we started building, like everyone else, when you say, I'm going to build something cheap, where I'm going to build it in China. And over the course of the last year, we've steadily reshored manufacturing of these things to the point where now 100% of these are being built in South Wales. So they're being built in the UK. So that level of support, having these kind of big UK PLCs on site has given us the kind of level of volume and the level of support that we needed in order to really make that happen.
What is really on this little chip? But that's like that's pretty much it, right?
That's pretty much it. And really you can see the Raspberry Pi almost as being a breakout board for that chip. So this chip's called BCM2835. It was designed here in Cambridge. It was designed by the team that I'm a member of, just about 2 miles away from here. It was originally intended as a coprocessor. It was intended as a multimedia coprocessor for mobile phone. So if you've got a mobile phone platform that's performing well, maybe it's halfway through its life, and you want to give it a bit of a shot in the arm and bring it up to particularly maybe 5 years ago, where we were moving from a world of really fairly simple mobile phones to a world in which every mobile phone is expected to have video playback and good camera processing and 3D graphics. That this can be used as a shot in the arm processor to allow you to bring an older platform up into the modern era. And then the last one of them grew an ARM, so this thing already had most of the other stuff you need. It could drive an HDMI display, could drive a standard definition display, have a 3D accelerator and a video accelerator and a camera processor and some DSP and a USB controller, which is kind of an unusual feature to have in there. And really what we found was that looking at this chip, man, we're only an ARM away. We're only an ARM core away from this being a computer, a single chip computer. So we were lucky enough to be able to get an ARM core into the last stepping of 2835, the final production step, grew an ARM 11. And that's what allows us to run Linux. The really interesting thing has been that a lot of what people have done with this has been hardware hacking. We have these GPIOs here, which for me kind of a little bit of an afterthought in the design, but in practice a lot of the cool stuff people have been doing, adults and children, have been about using this as a machine. Because you ask, is this just a cheap PC? What can this do that a PC can't do? And in a lot of ways it is just a cheap PC, but this stuff is something that your most expensive PC can't do without an add-on card. And so people have been taking these, they've been putting them in boats, and they've been putting them in planes, and they've been putting them under balloons and sending them up to the edge of space. And they've been using them to automate their homes. There's a wonderful example someone had the other day of an augmented microwave. He'd taken an old microwave and completely overhauled the user experience of using this microwave. So it had a new touch panel on. You had voice commands. It had a web interface so you could control it from your iPad. It had a barcode scanner so you could scan the product, and he built a database of the mapped barcodes to cooking instructions, so you could just scan it, put it in, and it would cook it for you. And he built this thing with the Raspberry Pi. It's given people access to a kind of a level of technology. It's given people access to a platform that they can use to do all this really amazing stuff. And it's wonderful because a lot of the people doing this are adults, right? But the lovely thing is, a lot of these things adults are doing with it feed immediately into the range of projects that are available for teachers. We take this and we take it into schools, and at the end of the lessons, mixed ability classes, at the end of the lessons, there's always a hardcore of kids, boys and girls, who you have to basically prize the thing out of their hands. Because, particularly if it's their first experience of programming, and even if they've done something very simple, like we often use a snake game. Even if they've done very simple stuff like change the colour of the snake or make the snake go a little bit faster, that kind of power, you can see in their eyes, that they're like, hang on a second, I can make this machine do what I want. And for a sizable minority of children, that's a really, like as it was for me, I think, a transformative experience.
哇，我第二周上完嘞。
国测是吗？
看一下后面还有什么。其实这堂课没有很长哎，
超快啊，一就没了，都不到半小时。
可是因为它是等于是只是带你入门而已，还是有很多课很难的。但够了，这一天可以把它上得完。 可以再难听一点。你这笑声真的是
夸张了，反应跟我一样。他很勇敢哎，他还敢杀那个会飞的蟑螂。要是我，就直接叫爸叫妈，不当机器人。
哇哦！
这是没有杀虫剂是不是？好逗。 个人现在这个时间不说就很奇怪。哈，听到没？
嗯，
哼哼。对，就只有他们有教功课，会听。
开睡。